So we are starting a new topic um, called similarities. Similarities and congruence. Similarities and congruence. So that is what we are starting. Now, let us pray as we begin. Father Lord, be with us as we learn this topic. Help us to understand everything. In Jesus' name we pray. Amen.
Amen.
So from the topic similarities, it talks about things which are similar to one another. If I have a small triangle here, I may have a big triangle which is similar to one another. They are not of the same size, but they are just similar the way they are looking.
Okay.
You can have a small cylinder or a huge cylinder and a small one. Just like that. So under this topic, we'll be finding what is called sides. We'll be finding sides of objects, sometimes height, using the comparing. We'll be finding area, we'll be finding volume. Okay?
Okay.
So we need to know that the sides, sides, height, length, they are represented by the ratio A to the ratio B. Okay?
Okay.
Area, somebody is trying to get in. Serena Chipman. Madam Chipman. So the area, when you are finding area, the ratios of area ratio, let me start it like this. Area, the ratio of area is S squared to the B squared. Did you get that?
Okay. Yes.
And then when you're finding volume, the ratio of volumes,
Yes.
A to the 3, b to the 3. You didn't write that 3 properly. Madam Shipman, how are you? Babutuka.
Good evening.
How are you?
I'm fine. Sorry I'm late.
It's okay. We are recording the session, but we haven't gone far in Madam Zen.
So,
We're just on the introduction.
all right.
Yeah, we're just saying similarities deals with things which are similar, and under similarities there is issue of finding area. There is issue of finding volume of object. There is issue of finding sides, height, length of object. Yeah, those things. So this is what we'll be using to find the volume. This is what we'll be using to find the ratios. Now let's do this. When you have when let's do finding area using side ratios. You are finding what? Area of objects. Finding area of objects using side ratios. If I ask you, especially Madam Jane, what are the ratios of side ratios? What are the ratios of the side ratios? How do you write the area of, I mean, the ratios of sides? It's A to the B, right? For you to find the area, you need to square these, the S squared and the B squared. Yes. Let's look at an example. This is an example. Two triangles have heights 2 centimeters and 4 centimeters respectively. Find A side ratios or height ratios, area ratios, the ratios of their area. Find ratios of their area. Did you get that? Two triangles, they have heights of 2 centimeter and 4 centimeter. Find the side ratios and the ratios of their area. So we know that the side ratios are A to the ratio B. So it's 2 centimeters to the ratio 4 centimeters. You cancel the centimeters, cancel the 2, which gives you 1, 2, 2. So those are the ratios of their sides. Those are the ratios of their sides. That's question 1. Question 2,
These similarities. This is paper what now?
paper
Paper
1.
one.
Yes, the whole entire June will be looking at paper 1.
What example was that we're looking at? Which paper?
No, we are just doing the topic first. We haven't started the exam papers.
All right.
This is the question.
Mm-hmm.
Two triangles have heights 2 centimeters and 4 centimeters respectively. Find the side ratios, 2 ratios of their area. So before we look at past papers, I want you to have an idea of what similarity is. What do we do? How do we find the side ratios? How do we find the volume ratios? How do we find the square ratios? So let me even put another one. Number 3, find the volume ratios on the same question. Find the volume what? Ratios. So what you should get from here, Madam Selina, is that when you're finding the sides, you use the formula A to the ratio B. When you're finding area, you use S squared to the ratio B squared. When you're finding volume, we use A to the 3, B to the 3. I don't know if you're getting it.
Mm-hmm.
Now, the question says, find the ratios of their area. So to find the ratios of their area, we apply this formula here
Mm-hmm.
using the sides. So
Mm-hmm.
meaning our sides it's 2, which we've reduced. It is no longer 2, it's 1 to 2. We reduced it. So our number 2, they are saying area. We are going to say S squared to the B squared. So we use what we've reduced, 1 squared to 2 squared. So 1 to 4. Those are the sides. Those are the ratios of their area. I don't know if you're getting it. So we're now going to volume. We apply this. So volume, we are going to say number 3. To find volume, we need to use A to the 3, B to the 3. So
You
our
already explained what congruence. I'm not sure
congruence.
how you pronounce that. Congruence.
Congruence means objects which have exactly the same height, same area, same length, everything is same. So they can't bring questions on congruence because congruence means exactly the same object. They'll bring questions on similarities because similarities, things are not the same, but they are just similar.
I see.
Yes. So our A is 1 to the cube. We've reduced this 1 and our B is 2 to the 3. So our volume is 1 to the 8. So don't lose focus. We started with the finding area and the volume using sides ratios. So now let's do this. This is now the interesting part. Our new subheading is going to be finding side ratios using area and volume. So how do you find side ratios using area and volume? So the side ratios, if it's area, you say A squared, you square root, and you also square root the B. Let me do this. Let me move this to my one. If you are finding the side ratios using area, so let me start it like this. So area is A squared to the B squared, isn't it? This is area. So the sides, we have to square root the A here, and we square root the B for us to find the 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 sides. We need to square root the areas that we've been given. You haven't gotten that. Let me give an example.
This same topic is just very confused and everything. I don't know if it's because I've not started with you from the beginning,
Yes,
but I feel very.
you haven't started with us, that's why. If the areas of two similar things are 4 centimeters squared and 25 centimeters squared, what 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 are the side ratios? What are their side ratios? Madam Jane, are you there? So I will make you understand, Madam Selina, from the examples. This question has area. Okay, Madam Selina. The question has area. What you should know about similarities is that it deals with objects, deals with area of object, volume of object. It deals with size of object, height of object. Then you just be alternating. It's either you're finding size, it's either you're finding area, it's either you're finding volume. So when you're given height, or when you're given height, it means they want you to find area or volume. When you're given area, it's either they want you to find the size or the volume. Okay? So here, what are we given in the question?
The sides.
There are squares here.
Oh yeah.
Squares
The
means
area.
area. So now what are they looking for? The sides, isn't it? So how you are given 4, you are given 4 centimeters squared, and you are given 25 centimeters squared. How are you going to find the sides? You square root. You square root. What is the square root of 4? 2. What is the square root of 25? 5. Meaning those are sides that you have found. If you were given the sides, they say, can you find the area? You square. You'll get back easy. I don't know if it's clicking. When you're finding area, you square. When you're finding the sides using the area, what do? You square root. Now, what happens when we are finding when we are given volume? We are given volume. Volume is A to the 3, B to the 3. So how can you find the sides? You cube root. Okay? You have to find the cube root of these numbers that you have. For you to get the sides, let me do an example. That's when you get it. Bagachabe, Madam Serena gets it. Example. If the volume of two similar cylinder is 8 centimeter cube and 27 centimeter cube. What is the ratio of their sides? Madam Serena, can you read what I have written here?
The volume of two similar cylinders is 8 centimeters cubic and 27 centimeters cubic. What is the ratio of the sides?
So we are looking for ratios of their sides. Volume. The sides, if you are given volume, the sides are cubed here. You cube the numbers that you are given. You've been given 8 centimeter cubed and you've been given 27 centimeter cubed. So, what is a cube root of 8? Which number can you multiply 3 times to get 8? And which number can you cube to get 27? 3. That's all. That's what we'll be dealing with. I don't know if it's now clicking or you need more examples, Madam Serene.
Yeah, there.
So now, now,
So the maybe just because I have the
ma'am?
question on it, maybe that's why I'm lost.
Uh-huh.
I'm saying that maybe because I've never seen, maybe that's why I'm confused. So what you're saying is that um for this particular question you'll be asked to find sides, area, and volume,
Yes.
and then to find sides. When they say sides alone, it's A ratio B.
When
Then
they
when they
say
say area,
area, it's
the
A
one that
squared.
area is A squared ratio B squared.
Yes.
Then volume A cubed B cubed.
Yes. But if they bring area and then they ask you to find sides, you say root of that number and root of the other number. Did you get that?
Say that again.
I'm saying now they have given you area. The area is already given. You can't square, isn't it? You've already been given the area. They want you to find the sides using the area. So you square root the numbers that you've been given.
Okay.
And if they've given you volume, for you to get the sides, you square root. You cube root. Okay?
Sorry, baby.
So that is how it's supposed to be done. Now, what happens when we are given area um, finding volume we start off finding volume using area. We go finding volume using area, not using the sides. Did you get that? Wait. Hello, hello. Is anybody there? We are no longer using sides. We are using volume. We are finding volume using area. Like they've given you the S squared. So how do you find volume? You first square root. Mwapeza A, mwapeza B. Are you getting the idea? When you find the normal A and the normal B, then now you say volume is equals to, you now cube root. You cube. You didn't get that. Let me give you an example. This is an example. If the area of two similar things are 4 centimeters squared and 3 centimeters squared, find the ratios of their volumes. If the area of two similar things are 4 centimeters squared and 3 centimeters squared, find the ratios of their volume. Are you there? So we are given 2. No. We are given 4. 4 centimeter squared and 3. Allow me to change. Can somebody change for me the 3 and put 9? On the previous question, just change and put 9 instead of 3. It should say 9 centimeter. The same question they've written. On the 3, put 9 centimeter. Huh? No, no, just change 3, put it 9. Mwachinja, you've changed 3 to you've put 9. What are we finding? We are finding volume.
Mm.
Don't rush and say cube root or cube. No. First square root. Area must be square rooted. What's a square root of 4? 2. What's a square root of 9? 3. We had 3 in the first place. There is no square root of 3. It will give us decimal. So now that we have square rooted now, we can find volume by saying 2 to the 3, 3 to the 3. So our volume ratios is going to be 8 to the ratio 27. Nishtua sana. Without centimeters or millimeters or anything. Are you following?
Mm.
Same. When finding area using volume, you first, since volume is like this sign, that's what volume is. You cube root, you will find the normal A. Then the area, you square root. You square. Nakendesa, that's them. Okay, no, yeah. So I must understand that we can them because example. Um. So an example is if the volume of 2 cylinders is 81. No, not 81. The volume of 2 cylinders is 125 and 64 respectively. Find ratio of area. Hey, what have we been given, Madam Jane? 125 and 64. Are you there? 125 centimeter cubed to the ratio 64. Volume go with cube root. Then cancel together with the centimeters. What's the cube root of 125? 5. What's the cube root of 64? 4. We are looking for area. So you square. So the answer gives you 25 to 16. That's all. End of topic. So now we are free to enter any past paper now and solve any question that we can come across. So I am just opening a past paper right now. We can start as far as 2016 paper 1 to check for what came. Are you there? Yeah, I have found it. You are there? You can write. It's saying I'm doing the recording, so I can't share the screen.
What number is the question?
The question is 2016 October, question 8B. Or I can screenshot right now and send in the group if you don't mind. Or I can read it loud. Which one?
Me, I'm looking at it right now.
We can just what?
You can read it out.
Okay, it says the best area. The what? Okay, abapwira abantu aba. We start off. Kuja kwamene. Okay. Oh, what's up? This is Teacher Mbanga. It's Chikaya. In case that Waishivana, she's a big man who has been teaching you. Yeah. Jen.
Tomato sauce and what this is needed and potatoes.
Sauce yazira. Mm. Okay, tomorrow. Okay. The question says. The question. Are you there on the question? It says. The question says. The base area of two containers are geometrically similar. Are you there? Are geometrically similar are 80 centimeters squared and 180 centimeters square. You are there? Full stop. If the capacity of the larger container is 54 liters, are you there? If the capacity of the larger container is 54 liters in number, calculate the capacity of the smaller one. Are you there? Okay, let's write another question so tingana solve fie nishi hapo. So that's 2016. October, we are going to 2017 July. Let me just wait for this to lock out. It says it's found under question. 2017 July. Oh, I found it. Question 4. 2017 July. It's a short one. Hello.
We are here.
Two things are geometrically similar. It's just 2 marks this question. Two things are geometrically similar. Are you there?
Mm-hmm.
If the ratio of their volume, hello?
Mm.
If the ratio of their volumes is 27 to the ratio to 64, 27 to the ratio 64, find the ratio of their curved surface areas. Find the ratio of their curved surface areas. You've written that? Okay.
Say the last part again, Chef.
Find the ratios of their curved surface areas. The first question, if I read it again, it is said at 2 Shanshan, somebody to read it.
The base of the two contents are geometrically similar, 80 centimeters squared and 180
Very
centimeters
good.
squared.
80 centimeters what? Squared to the ratio 180 centimeters squared, right?
Mm.
Devin?
Mm.
Mm-hmm.
So if the capacity of the larger container is 54 liters, calculate the capacity of the smaller one.
So what is liters? How many liters
Using
nation?
area,
I'm saying liters.
volume.
Liters, it's volume.
Mm-hmm.
You've seen that, huh?
Yes.
Liters, it's volume. So, the capacity. So, first thing first, these were areas, right? We can reduce this out, okay? And we can also reduce which number can enter here? 2, right? 2 can enter here how many times? 4, right?
Mm.
Devin? We're just reducing, we just want to reduce these numbers. 2 can enter here 9, right? So remember, our target is to find volume. So we can't find volume minus square root in this first. Because this is area and they are looking for volume. I don't know now if you're getting the idea now. Yes. So here this is 2 to the ratio 3. You see now we are moving.
Yeah.
And then we cube these now. Because liters, it's volume. So what we are getting is 28, sorry, and 27. Are you see now we are moving, Madam Selina?
Yes, although I feel that ECZ are very wicked for all these processes.
For 2 marks on top of it. So just tell me, that number they gave you 54 liters, it's for which? Is it a bigger tin or the
Container,
smaller tin? Ma'am?
the larger container.
Okay, meaning it's supposed to be below 27 because that's a larger number. Then here there is x, so we cross multiply. So without a calculator, can someone do 27x equals to 8 times 54? 27x, 8 times 4, it's 32, carry 3, 40, 43. So 432 over 27 over 27. Cancel. So our x is equals to, how many times can 27 enter 432? It will enter 16 times. Without a calculator, it will enter 16 liters.
Tell us how you found the recipe.
Very easy. There are so many ways in which you can do this. You can reduce. If you want, you can say 27 into, maybe the easy way is reducing. You can use, okay, you can use,
You can use long division.
yeah, but just try this. 27 into 40, or just use 3 maybe. 3 into 27, it's 9. 3 into 4, it's 1. Remember 1, you put it on this, it's 13. 3 in 13, it's 4. 3 in 3 so remember 1. So 3 in 12, 4. So meaning you've got 144 divided by 9. Again 3 there, 3. 3 there, it gives you 4. You put it here. Yeah. I mean to 2. 3 there, 28. So 3 into 48, it's 16. Done. Or 9 into 144, it's 16 times. Yep.
Just for 2 months.
Yep, just for 2 marks. That's why I had done these 2 small topics. Last, I knew what we were up to. The only idea calculus, those are 2 marks. Okay, the last, huh?
How many questions are in paper?
The last question says we've been given 27 and 64. They are looking for this is volume.
Chapman,
Yes, me.
just out of topic, just for a minute. How many questions should you answer in paper one for you to be safe?
As many as you can. As many
So
as you can. You have to answer all the major topics for you to be safe. For you to be safe, you have to answer the major topics. And what are the major topics?